The following is a conversation all about the state of the art in artificial intelligence, including some of the exciting technical breakthroughs and developments in AI that happened over the past year, and some of the interesting things we think might happen this upcoming year. At times, it does get super technical, but we do try to make sure that it remains accessible to folks outside the field without ever dumbing it down. It is a great honor and pleasure to be able to do this kind of episode with two of my favorite people in the AI community, Sebastian Raschke and Nathan Lambert. They are both widely respected machine learning researchers and engineers who also happen to be great communicators, educators, writers, and Twitterers, ex-posters. Sebastian is the author of 2 books I highly recommend for beginners and experts alike. First is Build a Large Language Model from Scratch and Build a Reasoning Model from Scratch. I truly believe in the machine learning computer science world, the best way to learn and understand something is to build it yourself from scratch. Nathan is the post-training lead at the Allen Institute for AI and author of the definitive book on reinforcement learning from human feedback. Both of them have great X accounts, great Substacks. Sebastian has courses on YouTube. Nathan has a podcast, and everyone should absolutely follow all of those. This is the Lex Friedman Podcast. To support it, please check out our sponsors in the description, where you can also find links to contact me, ask questions, get feedback, and so on. And now, dear friends, here's Sebastian Raschke and Nathan Lambert. So I think one useful lens to look at all of this through is the DeepSeek, so-called DeepSeek moment. This happened about a year ago in January 2025 when the open-weight Chinese company DeepSeek released DeepSeek R1 that I think it's fair to say surprised everyone with near or at state-of-the-art performance with allegedly much less compute for much cheaper. And from then to today, the AI competition has gotten insane, both on the research level and the product level. It's just been accelerating. Let's discuss all of this today, and maybe let's start with some spicy questions if we can. Who's winning at the international level? Would you say it's the set of companies in China or the set of companies in the United States? And Sebastian, Nathan, it's good to see you guys. So Sebastian, who do you think is winning?
So winning is a very broad, term. I would say you mentioned the DeepSeek moment, and I do think DeepSeek is definitely winning the hearts of the people who work on open weight models because they share these as open models. Winning, I think, has multiple timescales to it. We have today, we have next year, we have in 10 years. One thing I know for sure is that I don't think nowadays, 2026, that there will be any company who is, let's say, having access to a technology that no other company has access to. And that is mainly because researchers are frequently changing jobs, changing labs, they rotate. So I don't think there will be a clear winner in terms of technology access. However, I do think there will be the differentiating factor will be budget and hardware constraints. So I don't think the ideas will be proprietary, but the way or the resources that are needed to implement them. And so I don't see currently a take-it-all scenario where a winner takes it all. I can't see that at the moment.
Nathan, what do you think?
You see the labs put different energy into what they're trying to do. And I think to demarcate the point in time when we're recording this, the hype over Anthropic's Claude Opus 4.5 model has been absolutely insane, which is just, I mean, I've used it and built stuff in the last few weeks, and it's almost gotten to the point where it feels like a bit of a meme in terms of the hype. And it's kind of funny because this is very organic. And then if we go back a few months ago, we can get the release date in the notes as Gemini 3 from Google got released. And it seemed like the marketing and just like wow factor of that release was super high. But then at the end of November, Claude Opus 4.5 was released and the hype has been growing. But Gemini 3 was before this. And it kind of feels like people don't really talk about it as much, even though when it came out, everybody was like, this is Gemini's moment to retake kind of Google's structural advantages in AI. And Gemini 3 is a fantastic model and I still use it. It's just kind of differentiation is lower. And I agree with Sebastian, what you're saying with all of these, like the idea space is very fluid, but culturally Anthropic is known for betting very hard on code, which this Claude Code thing is working out for them right now. So I think that even if the ideas flow pretty freely, so much of this is bottlenecked by human effort and kind of culture of organizations, where Anthropic seems to at least be presenting as the least chaotic. It's a bit of an advantage. And if they can keep doing that for a while. But on the other side of things, there's a lot of ominous technology from China where there's way many more labs than DeepSeek. So DeepSeek kicked off a movement within China, I say kind of similar to how ChatGPT kicked off a movement in the US where everything had a chatbot. There's now tons of tech companies in China that are releasing very strong frontier open weight models, to the point where I would say that DeepSeek is kind of losing its crown as the preeminent open model maker in China, and the likes of Z.AIs with their GLM models, Minimax's models, Kimi Moonshot, especially in the last few months, have shown more brightly. The new DeepSeek models are still very strong, but that's kind of it could look back as a big narrative point where in 2025 DeepSeek came and it kind of provided this platform for way more Chinese companies that are releasing these fantastic models to kind of have this new type of operation. So these models from these Chinese companies are open weights, and depending on this trajectory of business models that these American companies are doing, could be at risk. But currently, a lot of people are paying for AI software in the US, and historically in China and other parts of the world, people don't pay a lot for software.
So some of these models like DeepSeek have the love of the people because they are open weight. How long do you think the Chinese companies keep releasing open weight models?
I would say for a few years. I think that, like in the US, there's not a clear business model for it. I have been writing about open models for a while, and these Chinese companies have realized it. So I get inbound from some of them. And they're smart and realize the same constraints, which is that a lot of US tech companies and other IT companies won't pay for a API subscription to Chinese companies for security concerns. This has been a long-standing habit in tech. And the people at these companies then see open weight models as an ability to influence and take part of a huge growing AI expenditure market in the US. And they're very realistic about this. And it's working for them. And I think that the government will see that that is building a lot of influence internationally in terms of uptake of the technology. So there's going to be a lot of incentives to keep it going. But building these models and doing the research is very expensive. So at some point, I expect consolidation, but I don't expect that to be a story of 2026, where there will be more open model builders throughout 2026 than there were in 2025. And a lot of the notable ones will be in China.
You were going to say something?
Yes, you mentioned DeepSeek losing its crown. I do think to some extent, yes, but we also have to consider, though, they are still, I would say, slightly ahead. And the other ones, it's not that DeepSeek got worse. It's just like the other ones are using the ideas from DeepSeek. For example, you mentioned Kimi, same architecture, they're training it. And then again, we have this leapfrogging where they might be at some point in time a bit better because they have the more recent model. And I think this comes back to the fact that there won't be a clear winner. It will just be like that. And one person releases something, the other one comes in, and the most recent model is probably always the best model.
Yeah. We'll also see the Chinese companies have different incentives. So like DeepSeek is very secretive, where some of these startups are like the Minimaxes and Z.AIs of the world. Those two literally have filed IPO paperwork, and they're trying to get Western mindshare and do a lot of outreach there. So I don't know if these incentives will kind of change the model development, because DeepSeek famously is built by a hedge fund, High Flyer Capital, and we don't know exactly what they like. We don't know what they use the models for, or if they care about this.
They're secret in terms of communication. They're not secret in terms of the technical reports that describe how their models work. They're still open on that front. And we should also say on the Opus 4.5 hype, there's the layer of something being the darling of the X echo chamber on Twitter, echo chamber, and the actual amount of people that are using the model. I think it's probably fair to say that ChatGPT and Gemini are focused on the broad user base that just want to solve problems in their daily lives. And that user base is gigantic. So the hype about the coding may not be representative of the actual use.
I would say also a lot of the usage patterns are, like you said, name recognition, brand and stuff, but also muscle memory almost, where, like ChatGPT has been around for a long time. People just got used to using it, and it's kind of like almost like a flywheel. They recommend it to other users and that stuff. One interesting point is also the customization of LLMs. For example, ChatGPT has a memory feature, right? And so you may have a subscription and you use it for personal stuff, but I don't know if you want to use that same thing at work, because it's a boundary between private and work. If you're working at a company, they might not allow that, or you may not want that. And I think that's also an interesting point where you might have multiple subscriptions. One is just clean code. It has nothing of your personal images or hobby projects in there. It's just like the work thing. And then the other one is your personal thing. So I think that's also something where two different use cases, and it doesn't mean you only have to have one. I think the future is also multiple ones.
What model do you think won 2025, and what model do you think is going to win 26?
I think in the context of a consumer chatbots is a question of, are you willing to bet on Gemini over ChatGPT, which I would say in my gut feels like a bit of a risky bet because OpenAI has been the incumbent and there's so many benefits to that in tech. But I think the momentum, if you look at 2025, was on Gemini's side, but they were starting from such a low point. I think RIP Bard and these earlier attempts of getting started, I think huge credit for them for powering through the organizational chaos to make that happen. But also it's hard to bet against OpenAI because they always come off as so chaotic, but they're very good at landing things. And I think personally, I have very mixed reviews of GPT-5, but I had to have saved them so much money with the headline feature being a router where most users are no longer charging their GPU costs as much. So I think it's very hard to dissociate the things that I like out of models versus the things that are going to actually be a general public differentiator.
What do you think about 2026? Who's going to win?
I'll say something, even though it's risky. I will say that I think Gemini will continue to take progress on ChatGPT. I think Google scale when both of these are operating at such extreme scales. And Google has the ability to separate that research and product a bit better, where you hear so much about OpenAI being chaotic operationally and chasing the high impact thing, which is a very startup culture. And then on the software and enterprise side, I think Anthropic will have continued to success as they've again and again been set up for that. And obviously Google's cloud has a lot of offerings, but I think this kind of Gemini name brand is important for them to build. And Google's cloud will continue to do well, but that's kind of a more complex thing to explain in the ecosystem because that's competing with the likes of Azure and AWS rather than on the model provider side.
So in the infrastructure, you think TPUs give an advantage?
Largely because the margin on NVIDIA chips is insane and Google can develop everything from top to bottom to fit their stack and not have to pay this margin. And they've had a head start in building data centers. So all of these things that have both high lead times and very hard margins on high costs, Google has just kind of a historical advantage there. And if there's going to be a new paradigm, it's most likely to come from OpenAI, where their research division again and again has kind of shown this ability to land a new research idea or a product. I think deep research, Sora, O1 thinking models, all of these definitional things have come from OpenAI, and that's got to be one of their top traits as an organization. So it's kind of hard to bet against that, but I think a lot of this year will be about scale and optimizing what could be described as low-hanging fruit in models.
And clearly, there's a trade-off between intelligence and speed. This is what ChatGPT 5 was trying to solve behind the scenes. It's do people actually want intelligence, the broad public, or do they want speed?
I think it's a nice variety, actually, or the option to have a toggle there. I mean, first, for my personal usage, most of the time when I look something up, I use ChatGPT to ask a quick question, get the information I wanted fast. For, most daily tasks, I use the quick model. Nowadays, I think the auto mode is pretty good, where you don't have to specifically say thinking or, non-thinking and stuff. Then again, I also sometimes want the pro mode. Very often what I do is when I have something written, I put it into a ChatGPT and say, hey, do a very thorough check. Are all my references correct? Are all my thoughts correct? Did I make any formatting mistakes? And are the figure numbers wrong or something like that? And I don't need that right away. It's something, okay, I finish my stuff, maybe have dinner, let it run, come back and go through this. And I think, this is where I think it's important to have this option. I would go crazy if for each query I would have to wait 30 minutes or 10 minutes each.
That's me.
Yeah.
I'm like sitting over here losing my mind that you use the router and the non-thinking model. I'm like, oh, how do you live with that?
Yeah.
It's like my reaction. I'm been heavily on ChatGPT for a while. Never touched 5 non-thinking. I find its tone and then its propensity of errors. It's just like it has a higher likelihood of errors. Some of this is from back when OpenAI released O3, which was the first model to do this deep search and find many sources and integrate them for you. So I became habituated with that. So I will only use GPT 5.2 Thinking or Pro when I'm finding any sort of information query for work, whether that's a paper or some code reference that I found. And it's just like, I will regularly have like 5 pro queries going simultaneously, each looking for one specific paper or feedback on an equation or something.
I have a fun example where I just needed the answer as fast as possible. For this podcast, before I was going on the trip, I have like a local GPU running at home, and I wanted to run a long RL experiment. And usually I also unplug things, because you never know, if you're not at home, you don't want to have things plugged in. And I accidentally unplugged the GPU. It was like my wife was already in the car, and it's like, oh, dang. And then basically I wanted as fast as possible a bash script that runs my different experiments and the evaluation. And I did something I know. I learned how to use the bash interface or bash terminal. But in that moment, I just needed like 10 seconds. Give me the command.
This is a hilarious situation, but yeah. So what did you use?
So I did the non-thinking fastest model. It gave me the bash command to chain different scripts to each other. And then the thing is, like, you have the T thing where you want to route this to a log file. Top of my head, I was just like in a hurry. I could have thought about it myself.
By the way, I don't know if there's a representative case, wife waiting in the car, you have to run, you unplug the GPU, you have to generate a bash script. This sounds like a movie, like Mission Impossible.
I use Gemini for that. So I use Thinking for all the information stuff, and then Gemini for fast things or stuff that I could sometimes Google, which is like, it's good at explaining things, and I trust that it has this kind of background of knowledge, and it's simple. And the Gemini app has gotten a lot better, and it's good for that sort of things. And then for code and any sort of philosophical discussion, I use Claude Opus 4.5, also always with extended thinking. Extended thinking and inference time scaling is just a way to make the models marginally smarter. And I will always edge on that side when the progress is very high, because you don't know when that'll unlock a new use case. And then sometimes use Grok for real-time information, or finding something on AI Twitter that I knew I saw and I need to dig up, and I just fixated on. Although when Grok 4 came out, the Grok 4, what is super heavy, which was like their pro variant, was actually very good. And I was pretty impressed with it. And then I just kind of like muscle memory lost track of it with having the ChatGPT app open. So I use many different things.
Yeah. I actually do use Grok 4 heavy for debugging, for like hardcore debugging that the other ones can't solve it. I find that it's the best at. And it's interesting because you say ChatGPT is the best interface. For me, for that same reason, but this could be just momentum. Gemini is the better interface for me. I think because I fell in love with their best needle in the haystack. If I ever put something that has a lot of context, but I'm looking for very specific kinds of information, make sure it tracks all of it. I find at least the Gemini for me has been the best. So it's funny with some of these models, if they win your heart over for one particular feature on a one particular day for that particular query, that prompt, you're like, this model is better. And so you'll just stick with it for a bit until it does something really dumb. There's like a threshold effect, some smart thing, and then you fall in love with it, and then it does some dumb thing, and you're like, you know what? I'm going to switch and try Claude or ChatGPT and all that kind of stuff.
This is exactly like you use it until it breaks, until you have a problem, and then you change the LLM. And I think it's the same how we use anything, like our favorite text editor, operating systems, or the browser. I mean, there are so many browser options: Safari, Firefox, Chrome, all relatively similar. But then there are edge cases, maybe extensions you want to use, and then you switch. But I don't think there is any one who types the same thing, like the website, into different browsers and compares them. You only do that when the website doesn't render, if something breaks, I think. So that's a good point. I think you use it until it breaks, and then you explore other options, I think.
on the long context thing. I was also a Gemini user for this, but the GPT 5.2 release blog had like crazy long context scores where a lot of people were like, did they just figure out some algorithmic change? It went from like 30% to like 70% or something in this minor model update. So it's also very hard to keep track of all of these things. But now I'm look more favorably at GPT 5.2's long context. So it's just kind of like, how do I actually get to testing this never-ending battle?
Well, it's interesting that none of us talked about the Chinese models from a user usage perspective. What does that say? Does that mean the Chinese models are not as good, or does that mean we're just very biased and US focused?
I do think that that's currently the discrepancy between just the model and the platform. So I think the open models, they are more known for the open weights, not their platform yet.
There are also a lot of companies that are willing to sell you the open model inference at a very low cost. I think like OpenRouter, it's easy to do the look at multi-model things. You could run DeepSeek on Perplexity. I think all of us sitting here are like, we use OpenAI GPT-5 Pro consistently. We're all willing to pay for the marginal intelligence gain. And anyone that's like these models from the US are better in terms of the outputs. I think that the question is, will they stay better for this year and for years going? But it's like, so long as they're better, I'm going to pay for it to use them. I think there's also analysis that shows that like the way that the Chinese models are served, this you could argue due to expert controls or not, is that they use fewer GPUs per replica, which makes them slower and have different errors. And it's like speed and intelligence. If these things are in your favor as a user, I think in the US, a lot of users will go for this. And I think that that is something that will spur these Chinese companies to want to compete in other ways, whether it's like free or substantially lower costs, or it'll breed creativity in terms of offerings, which is good for the ecosystem. But I just think the simple thing is the US models are currently better and we use them. And I try I try these other open models and I'm like, fun, but I don't go back to it.
We didn't really mention programming. That's another use case that a lot of people deeply care about. So I use basically half and half Cursor and Claude Code because I find them to be like fundamentally different experience and both useful. What do you program quite a bit. So what do you use? What's the current vibe?
So I use the Codex plugin for VS Code. It's very convenient. It's just like a plugin, and then it's a chat interface that has access to your repository. I know that Claude Code is, I think, a bit different. It's a bit more agentic. It touches more things. It does the whole project for you. I'm not quite there yet where I'm comfortable with that because maybe I'm a control freak, but I still would like to see a bit what's going on. And Codex is kind of like right now for me, like the sweet spot where it is helping me, but it is not taking completely over.
I should mention one of the reasons I do use Claude Code is to build the skill of programming with English. I mean, the experience is fundamentally different. As opposed to micromanaging the details of the process of the generation of the code and looking at the diff, which you can in Cursor, if that's the ID you use, and in changing, altering, looking and reading the code and understanding the code deeply as you progress versus just kind of like thinking in this design space and just guiding it at this macro level, which I think is another way of thinking about the programming process. Also, we should say that Claude Code, it just seems to be somehow a better utilization of Claude Opus 4.5.
It's a good side-by-side for people to do. So you can have Claude Code open, you can have Cursor open, you can have VS Code open, and you can select the same models on all of them and ask questions. And it's very interesting. Like the Claude Code is way better in that domain. It's remarkable.
All right. We should say that both of you are legit on multiple fronts: researchers, programmers, educators, tweeterers, and on the book front too. So Nathan, at some point soon, hopefully has an RLHF book coming out.
It's available for pre-order and there's a full digital preprint. I'm just making it pretty and better organized for the physical thing, which is a lot of why I do it, because it's fun to create things that you think are excellent in the physical form when so much of our life is digital.
I should say, going to Perplexity here, Sebastian Roschke is a machine learning researcher and author known for several influential books. A couple of them that I wanted to mention, which is a book I highly recommend, Build a Large Language Model from Scratch, and the new one, Build a Reasoning Model from Scratch. So I'm really excited about that. Building stuff from scratch is one of the most powerful ways of learning.
honestly, building an LLM from scratch is a lot of fun. It's also a lot to learn. And like you said, it's probably the best way to learn how something really works, because you can look at figures, but figures can have mistakes. You can look at concepts, explanations, but you might misunderstand them. But if you see there is code and the code works, you know it's correct. I mean, there's no misunderstanding. It's like, it's precise. Otherwise it wouldn't work. And I think that's like kind of like the beauty behind coding. It is kind of like, it doesn't lie. It's math, basically. So even though with math, I think you can have mistakes in a book you would never notice because you're not running the math when you're reading the book. You can't verify this. And with code, what's nice is you can verify it.
Yeah, I agree with you about the LLM from scratch book. It's nice to tune out everything else, the internet and so on, and just focus on the book. But, I read several history books. It's just less lonely somehow. It's really more fun. Like, for example, on the programming front, I think it's genuinely more fun to program with an LLM. And I think it's genuinely more fun to read with an LLM. But you're right. Like, this distraction should be minimized. So it's, you use the LLM to basically enrich the experience, maybe add more context. Maybe the rate of aha moments for me in a small scale is really high with LLMs.
100%. I also want to correct myself. I'm not suggesting not to use LLMs. I suggest doing it in multiple passes, like one pass just offline, focus mode. And then after that, I also take notes, but I try to resist the urge to immediately look things up. I do a second pass. It's just like for me more structured this way. And I get, sometimes things are answered in the chapter, but sometimes also it just helps to let it sink in and think about it. Other people have different preferences. I would highly recommend using LLMs when reading books. For me, it's not the first thing to do. It's like the second pass.
By way of recommendation, as to say, I do the opposite. I like to use the LLM at the beginning to lay out the full context of like, what is this world that I'm now stepping into? But I try to avoid clicking out of the LLM into the world of like Twitter and blogs. And because then you're now down this rabbit hole, you're reading somebody's opinion. There's a flame war about a particular topic. And all of a sudden you're now in the realm of the internet and Reddit and so on. But if you're purely letting the LLM give you the context of why this matters, what are the big picture ideas. But sometimes books themselves are good at doing that, but not always. So
this is why I like the ChatGPT app. It gives the AI a home in your computer when you can focus on it rather than just being another tab in my mess of internet options. And I think Claude Code in these particular does a good job of making that a joy, where it seems very engaging as a product designed to be an interface that your AI will then go out into the world. And it's something that is very kind of intangible between it and Codex, is that it just feels kind of warm and engaging, where Codex can often be as good from OpenAI, but it just kind of like feels a little bit rougher on the edges, whereas like Claude Code makes it fun to build things, particularly from scratch, where you just you don't have to care, but you trust that it'll make something. Like obviously this is good for websites and kind of refreshing tooling and stuff like this, which I use it for, or data analysis. So my blog, we scrape Hugging Face. So we keep the download numbers for every data set and model over time now. So we have them. And it's like Claude was just like, yeah, I've made use of that data, no problem. And I was like, that would have taken me days. And it's like, and then I have enough situational awareness to be like, okay, these trends obviously make sense and you can check things. But that's just the kind of wonderful interface where you can have an intermediary and not have to do the kind of awful low-level work that you would have to do to maintain different web projects and do this stuff.
All right, so we just talked about a bunch of the closed weight models. Let's talk about the open ones. So tell me about the landscape of open LLM models. Which are interesting ones, which stand out to you, and why? We already mentioned DeepSeek.
Do you want to see how many we can name off the top of our head?
Yeah, without looking at notes.
DeepSeek, Kimi, Minimax, Z.ai, Antling. We're just going Chinese.
Let's throw in Mistral AI, Gemma. GPT OSS, the open source model by ChatGPT. Actually, NVIDIA had a very cool one, Nemotron 3. There's a lot of stuff, especially at the end of the year. Qwen, one maybe the one.
Oh yeah, Qwen was the obvious name I was just saying. I was trying to get through you can get at least 10 Chinese and at least 10 Western. I think that I mean, OpenAI released their first open model since GPT-2. That was when I was writing about OpenAI's open model release. They're all like, "Don't forget about GPT-2," which I thought was really funny because it's just such a different time. But GPT-OSS is actually a very strong model and does some things that the other models don't do very well. And I think that selfishly, I'll promote a bunch of like Western companies. So both in the US and Europe have these like fully open models. So I work at Allen Institute for AI. We've been building Olmo, which releases data and code and all of this. And now we have actual competition for people that are trying to release everything so that other people can train these models. So there's the Institute for Foundation Models or / LM 360, which is like had their K2 models of various types. Aperdis is a Swiss research consortium. Hugging Face has small LM, which is very popular. And NVIDIA's Nematron has started releasing data as well. And then Stanford's Marin Community Project, which is kind of making it so there's a pipeline for people to open a GitHub issue and implement a new idea and then have it run in a stable language modeling stack. So this space, that list was way smaller in 2024. Mm-hmm. So I think it was like just AI2. So that's a great thing for more people to get involved and to understand language models, which doesn't really have a Chinese company that has an analog. While I'm talking, I'll say that the Chinese open language models tend to be much bigger, and that gives them this higher peak performance as MOEs, where a lot of these things that we like a lot, whether it was Gemma and Nematron, have tended to be smaller models from the US, which is starting to change from the US and Europe. Mistral Large 3 came out, which was a giant MOE model, very similar to DeepSeek architecture in December. And then a startup, RCAI, and both Nematron and NVIDIA have teased MOE models of this way bigger than 100 billion parameters, so like this 400 billion parameter range coming in this like Q1 2026 timeline. So I think this kind of balance is set to change this year in terms of what people are using the Chinese versus US open models for, which I'm personally going to be very excited to watch.
First of all, huge props for being able to name so many of these. Did you actually name Llama?
No.
I feel like
R.I.P.
This was not on purpose.
R.I.P. Llama.
Mm-hmm.
All right. Can you mention what are some interesting models that stand out? So you mentioned Qwen 3 is obviously a standout.
So I would say the year's almost bookended by both DeepSeek version 3 and R1. And then on the other hand, in December, DeepSeek version 3.2, because what I like about those is they always have an interesting architecture tweak that others don't have. But otherwise, if you want to go with, like the familiar but really good performance, Qwen 3 and like Nathan said, also GPT-OSS. And I think GPT-OSS, what's interesting about it is kind of like the first public or like open weight model that was really trained with tool use in mind, which I do think is kind of a little bit of a paradigm shift where the ecosystem was not quite ready for it. So with tool use, I mean that the LLM is able to do a web search, to call a Python interpreter. And I do think it's a standout because I think it's a huge unlock, because one of the most common complaints about LLMs are, for example, hallucinations, right? And so in my opinion, one of the best ways to solve hallucinations is to not try to always remember information or make things up. For math, why not use a calculator app or Python? If I ask the LLM who won the soccer World Cup in 1998, instead of just trying to memorize, it could go do a search. I think mostly it's usually still a Google search. So ChatGPT, GPT-OSS, they would do a tool call to Google, maybe find the FIFA website, find, okay, it was France. It would get you that information reliably instead of just trying to memorize it. So I think it's a huge unlock, which I think right now is not fully utilized yet by the open source, open weight ecosystem. A lot of people don't use tool call modes because I think it's a trust thing. You don't want to run this on your computer where it has access to tools, could wipe your hard drive or whatever. So you want to maybe containerize that. But I do think, that is like a really important step for the upcoming years to have this ability. Yeah.
So a few quick things. First of all, thank you for defining what you mean by tool use. I think that's a great thing to do in general for the concepts we're talking about. Even things as sort of well established as MOEs, you have to say that means mixture of experts, and you kind of have to build up an intuition for people what that means, how it's actually utilized, what are the different flavors. So what does it mean that there's just such explosion of open models? What's your intuition?
if you're releasing an open model, you want people to use it as the first and foremost thing. And then after that comes things like transparency and trust. I think when you look at China, the biggest reason is that they want people around the world to use these models. And I think a lot of people will not. If you look outside of the US, a lot of people will not pay for software, but they might have computing resources where you can put a model on it and run it. I think there can also be data that you don't want to send to the cloud. So the number one thing is getting people to use models, use AI or use your AI that might not be able to do it without having access to the model.
I guess we should state explicitly. So we've been talking about these Chinese models and open weight models. Oftentimes the way they're run is locally. So it's not like you're sending your data to China or to whoever developed, to Silicon Valley, whoever developed the model.
A lot of American startups make money by hosting these models from China and selling tokens. It's called like selling tokens, which means somebody will call the model to do some piece of work. I think the other reason is for US companies, like OpenAI is so GPU deprived. Like they're at the limits of the GPUs. Whenever they make a release, they're always talking about like our GPUs are hurting. And I think there's like in one of these like GPT OSS release sessions, Sam Altman said like, "Oh, we're releasing this because we can use your GPUs. We don't have to use our GPUs, and OpenAI can still get distribution out of this," which is another very real thing because it doesn't cost them anything.
And for the user, I think also, I mean, there are users who just use the model locally, how they would use ChatGPT, but also for companies, I think it's a huge unlock to have these models because you can customize them, you can train them, you can add post-training, add more data, like specialize them into, let's say, law, medical models, or whatever you have. And the appeal, you mentioned Llama, the appeal of the open weight models from China is that the open weight models are also, the licenses are even friendlier. I think they are just unrestricted open source licenses where if you use something like Llama or Gemma, there are some strings attached. I think it's like an upper limit in terms of how many users you have. And then if you exceed, I don't know, so and so many million users, you have to report your finance situation to, let's say, Meta or something like that. And I think, well, it is a free model, but there are strings attached and people do like things where strings are not attached. So I think that's also one of the reasons, besides performance, why the open weight models from China are so popular, because you can just use them. There's no catch in that sense. Yeah.
The ecosystem has gotten better on that front, but mostly downstream of these new providers providing such open licenses. That was funny when you pulled up Perplexity. It said Kimi K2 Thinking hosted in the US, which is just like an exact, I've never seen this, but it's an exact example of what we're talking about where people are sensitive to this. Like Kimi K2 Thinking and Kimi K2 is a model that is very popular. People say that has very good like creative writing and also in doing some software things. So it's just these little quirks that people pick up on with different models that they like.
What are some interesting ideas that some of these models have explored that you can speak to, like that particular interesting to you?
Maybe we can go chronologically. I mean, there was, of course, DeepSeek R1 that came out in January, if we just focus on 2025. However, this was based on DeepSeek version 3, which came out the year before in December 2024. There are multiple things on the architecture side. What is fascinating is you can still, I mean, that's what I do in my from scratch coding projects. You can still start with GPT-2 and you can add things to that model to make it into this other model. So it's all still kind of like the same lineage, it is a very close relationship between those. But top of my head, DeepSeek, what was unique there is the mixture of they were not inventing mixture of experts. We can maybe talk a bit more what mixture of experts means. But just to list these things first before we dive into detail, mixture of experts, but then they also had multi-head latent attention, which is a tweak to the attention mechanism, where this was, I would say, 2025, the main distinguishing factor between these open weight models, different tweaks to make inference or KV cache size. We can also define KV cache in a few moments, but to kind of make it more economical to have long context, to shrink the KV cache size. So what are tweaks that we can do? And most of them focused on the attention mechanism. There is multi-head latent attention in DeepSeek. There is group query attention, which is still very popular. It's not invented by any of those models. It goes back a few years, but that would be the other option. Sliding window attention, I think almost 3 uses it, if I remember correctly. So there are these different tweaks that make the models different. Otherwise, I put them all together in an article once where I just compared them. They are very surprisingly similar. It's just different numbers in terms of how many repetitions of the transformer block you have in the center. And like just little knobs that people tune. But what's so nice about it is it works no matter what. You can tweak things. You can move the normalization layers around. You get some performance gains. And OMO is always very good in ablation studies, showing what actually what it does to the model if you move something around. Ablation studies, does it make it better or worse? But there are so many, let's say, ways you can implement a transformer and make it still work. Big ideas that are still prevalent is mixture of experts, multi-head latent attention, sliding window attention, group query attention. And then at the end of the year, we saw a focus on making the attention mechanism scale linearly with inference token prediction. So there were Qwen3 Next, for example, which added a gated delta net. It's like kind of like inspired by state space models where you have a fixed state that you keep updating, but it makes essentially this attention cheaper, or it replaces attention with a cheaper operation.
And it maybe is useful to step back and talk about transform architecture in general.
Yeah, so maybe we should start with the GPT-2 architecture. The transformer that was derived from the attention is all you need paper. Mm-hmm. So the attention is all you need paper had a transformer architecture that had two parts, an encoder and a decoder. And GPT went just focusing in on the decoder part. It is essentially still a neural network, and it has this attention mechanism inside. And you predict one token at a time. You pass it through an embedding layer. There's the transformer block. The transformer block has attention modules and a fully connected layer. And there are some normalization layers in between. But it's essentially neural network layers with this attention mechanism. So coming from GPT-2, when we move on to GPT-OSS, there is, for example, the mixture of experts layer. It's not invented by GPT-OSS. It's a few years old. But it is essentially a tweak to make the model larger without consuming more compute in each forward pass. So there is this fully connected layer. And if listeners are familiar with multi-layer perceptrons, you can think of a mini multi-layer perceptron, a fully connected neural network layer inside the transformer. And it's very expensive because it's fully connected. If you have 1,000 inputs, 1,000 outputs, that's like 1 million connections. And it's a very expensive part in this transformer. And the idea is to kind of expand that into multiple feed-forward networks. So instead of having one, let's say you have 256, but it would make it way more expensive because now you have 256, but you don't use all of them at the same time. So you now have a router that says, okay, based on this input token, it would be useful to use this fully connected network. And in that context, it's called an expert. So a mixture of experts means you have multiple experts. And depending on what your input is, let's say it's more math heavy, it would use different experts compared to, let's say, translating input text from English to Spanish. It would maybe consult different experts. It's not quite clear, as clear cut to say, okay, this is only an expert for math and for Spanish is a bit more fuzzy. But the idea is essentially that you pack more knowledge into the network, but not all the knowledge is used all the time. Mm-hmm. That would be very wasteful. So you're kind of like during the token generation, you're more selective. There's a router that selects which tokens should go to which expert. It's more complexity. It's harder to train. There's a lot of, that can go wrong, like collapse and everything. So I think that's why Olmo 3 still uses dense. You have, I think, Olmo models with mixture of experts, but dense models, where dense means also it's jargon. There's a distinction between dense and sparse. So mixture of experts is considered sparse because we have a lot of experts, but only few of them are active. So that's called sparse. And then dense would be the opposite, where you only have like one fully connected module and it's always, utilized.
So maybe this is a good place to also talk about KV cache, but actually before that, even zooming out, like fundamentally, how many new ideas have been implemented from GPT-2 to today? Mm-hmm. Like how different really are these architectures?
Picture like the mixture of experts. The attention mechanism in GPT-OSS, that would be the group query attention mechanism. So it's a slight tweak from multi-head attention to group query attention. So there we have two. I think they replaced layer norm by RMS norm, but it's just like a different normalization layer. Not a big change. It's just like a tweak. The nonlinear activation function, people familiar with deep neural networks, it's the same as changing sigmoid with ReLU. It's not changing the network fundamentally. It's just like a tweak, like a little tweak. And that's about it, I would say. It's not really fundamentally that different. It's still the same architecture. So you can convert you can go from one into the other by just adding these changes, basically.
It fundamentally is still the same architecture.
Yep. So, for example, you mentioned my book earlier. That's a GPT-2 model in the book because it's simple and it's very small. So 120 million parameters approximately. But in the bonus materials, I do have almost 3 from scratch, Gemma 3 from scratch, and other types of from scratch models. And I always started with my GPT-2 model and just, tweaked added different components, and you get from one to the other. It's kind of like a lineage in a sense. Yeah.
Can you build up an intuition for people? Because sort of when you zoom out, you look at it, there's so much rapid advancement in the AI world. And at the same time, fundamentally, the architectures have not changed.
Mm-hmm.
So where is all the turbulence, the turmoil of the advancement happening? Where's the gains to be had?
So there are the different stages where you develop the network or train the network. You have the pre-training. Now, back in the day, it was just pre-training with GPT-2. Now you have pre-training, mid-training, and post-training. So I think right now we are in the post-training focus stage. I mean, pre-training still gives you advantages if you scale it up to better, higher quality data. But then we have capability unlocks that were not there with GPT-2. For example, ChatGPT, it is basically a GPT-3 model, and GPT-3 is the same as GPT-2 in terms of architecture. What was new was adding the supervised fine-tuning and the reinforcement learning with human feedback. So it's more on the algorithmic side rather than the architecture.
I would say that the systems also change a lot. I think if you listen to NVIDIA's announcements, they talk about these things like you now do FP8, you can now do FP4, and what is happening is these labs are figuring out how to utilize more compute to put it into one model, which lets them train faster, and that lets them put more data in, and then you can find better configurations faster by doing this. So you can look at essentially the tokens per second per GPU is a metric that you look at when you're doing large scale training, and you can go from 10K to 13K by turning on FP8 training, which means you're using less memory per parameter in the model. And by saving less information, you do less communication, you can train faster. So all of these system things underpin way faster experimentation on data and algorithms. That is kind of it's this kind of loop that keeps going where it's kind of hard to describe when you look at the architecture and they're exactly the same, but the code base used to train these models is going to be vastly different. Mm-hmm. And you could probably, the GPUs are different, but you probably train GPT-OSS 20B way faster in wall clock time than GPT-2 was trained at the time.
Yep, like you said, they had, for example, in the mixture of experts, this FP4 optimization, for example, where you get more throughput. But I do think this is, for the speed, this is true, but it doesn't give the model new capabilities in a sense. It's just how much can we make the computation coarser without suffering in terms of model performance degradation. But I do think, there are alternatives popping up to the transformer. There's text diffusion models, completely different paradigm. And there's also, although text diffusion models might use transformer architectures, but it's not an auto-regressive transformer. And also Mamba models, it's a state space model, but they do have trade-offs. And what's right is there's nothing that has replaced the auto-regressive transformer as state-of-the-art model. So for state-of-the-art, you would still go with that thing. But there are now alternatives for the cheaper and alternatives that are kind of making compromises, but it's not just one architecture anymore. There are little ones coming up. But if we talk about the state-of-the-art, it's pretty much still the transformer architecture, autoregressive, derived from GPT-2 essentially.
I guess the big question here is, we talked quite a bit here on the architecture behind the pre-training. Are the scaling laws holding strong across pre-training, post-training, inference, context size, data, synthetic data?
I like to start with the technical definition of scaling law, which kind of informs all of this. The scaling law is a power law relationship between, you can think of the x-axis, so kind of what you are scaling is a combination of compute and data, which are kind of similar. And then the y-axis is the held out prediction accuracy over next tokens. We talked about models being autoregressive. It's if you keep a set of text that the model has not seen, how accurate will it get when you will train? And the idea of scaling laws came when people figured out that was a very predictable relationship. And I think that technical term is continuing. And then the question is what do users get out of it? And then there are more types of scaling where OpenAI's O1 was famous for introducing inference time scaling. And I think less famously for also showing that you can scale reinforcement learning training and get kind of this log x-axis and then a linear increase in performance on y-axis. So there's kind of these three axes now where the traditional scaling laws are talked about for pre-training, which is how big your model is and how big your data set is, and then scaling reinforcement learning, which is like how long can you do this trial and error learning that we'll talk about. We'll define more of this. And then this inference time compute, which is just letting the model generate more tokens on a specific problem. So I'm kind of bullish where they're all really still working, but the low-hanging fruit has mostly been taken, especially in the last year on reinforcement learning with verifiable rewards, which is this RLVR, and then inference time scaling, which is just why these models feel so different to use, where previously you would get that first token immediately, and now they'll go off for seconds, minutes, or even hours generating these hidden thoughts before giving you the first word of your answer. And that's all about this inference time scaling, which is such a wonderful kind of step function in terms of how the models change abilities. They kind of enabled this tool use stuff and enabled this much better software engineering that we were talking about. And this is, when we say enabled, almost entirely downstream of the fact that this reinforcement learning with verifiable rewards training just kind of let the models pick up these skills very easily. So let the models learn. So if you look at the reasoning process, when the models are generating a lot of tokens, what it will be often doing is it tries a tool, it looks at what it gets back. It tries another API, it sees what it gets back, and if it solves the problem. So the models, when you're training them, very quickly learn to do this. And then at the end of the day, that gives this kind of general foundation where the model can use CLI commands very nicely in your repo and handle Git for you and move things around and organize things or search to find more information, which if we're sitting in these chairs a year ago is something that we didn't really think of the models being doing. So this is just kind of something that has happened this year and has totally transformed how we think of using AI, which I think is very magical. It's such an interesting evolution and just so unlocks so much value. But it's like, it's not clear what the next avenue will be in terms of unlocking stuff like this. I think that we'll get to continual learning later, but there's a lot of buzz around certain areas of AI, but no one knows when the next step function will really come.
So you've actually said quite a lot of things there and said profound things quickly. It would be nice to unpack them a little bit. You said you're bullish basically on every version of scaling. So can we just even start at the beginning? Pre-training. Are we kind of implying that the low-hanging fruit on pre-training scaling has been picked? Is pre-training hit a plateau, or is even pre-training still you're bullish on?
Pre-training has gotten extremely expensive. I think to scale up pre-training, it's also implying that you're going to serve a very large model to the users. So I think that it's been loosely established the likes of GPT-4 and similar models were around 1 trillion, like this order of trillion parameters at the biggest size. There's a lot of rumors that they've actually gotten smaller as training has gotten more efficient. You want to make the model smaller because then your costs of serving go down proportionally. These models, the cost of training them is really low relative to the cost of serving them to hundreds of millions of users. I think DeepSeek had this famous number of about $5 million for pre-training at cloud market rates. I think almost 3. Section 2.4 in the paper, we just detailed how long we had the GPU clusters sitting around for training, which includes engineering issues, multiple seeds, and it was like about $2 million to rent the cluster to like deal with all the problems and headaches of training a model. So these models are pretty, like a lot of people could get $1 to $10 million to train a model, but the recurring costs of serving millions of users is really billions of dollars of compute. I think that you can look at like 1,000 GPU rental, you can pay $100,000 a day for, and these companies could have millions of GPUs. Like you can look at how much these things cost to sit around. So that's kind of a big thing. And then it's like, if scaling is actually giving you a better model, like, is it going to be financially worth it? And I think it'll kind of slowly will push it out as AI solves more compelling tasks. So like the likes of Claude Opus 4.5, making Claude code just work for things. I think I launched this project called like the Atom Project, which is like American Truly Open Models in July. And that was like a true vibe coded website. and like I have a job, make plots and stuff. And then I came back to refresh it in the last few weeks. And it's like Claude Opus 4.5 versus whatever model at the time was like just crushed all the issues that it had from building in June and July. And like, it might be a bigger model. There's a lot of things that go into this, but that's like, there's still progress coming.
So what you're speaking to is the nuance of the y-axis of the scaling laws, that the way it's experienced versus on a benchmark, the actual intelligence might be different. But still, your intuition about pre-training, if you scale the size of compute, will the models get better? Not whether it's financially viable, but just from the law aspect of it. Do you think the models will get smarter?
Yeah. And I think that and this sometimes comes off as like almost like disillusioned from people, leadership like AI companies saying this, but they're like, it's held for 13 orders of magnitude of compute or something. Like, why would it ever end? So I think fundamentally it is pretty unlikely to stop. It's just like eventually we're not even going to be able to test the bigger scales because of all the problems that come with more compute. I think that there's a lot of talk on how 2026 is a year when very large Blackwell compute clusters, it's like gigawatt scale facilities that hyperscalers are coming online. And these were all contracts for power and data centers that were signed and sought out in like 22 and 2023. So before or right after ChatGPT. So it took this 2 to 3 year lead time to build these bigger clusters to train the models. While there's obviously immense interest in building even more data centers than that. So that is like kind of the crux that people are saying is like these new clusters are coming. The labs are going to have more compute for training. They're going to utilize this, but it's not a given. And it's like, I've seen so much progress that I expect it, and I expect a little bit bigger models, and I expect, I would say it's more like we will see a $2,000 subscription this year. We've seen $200 subscriptions. It's like that could 10x again. And these are the kind of things that could come, and they're all downstream of this like bit bigger model that offers just a little bit more cutting edge.
So, it's reported that XAI is going to hit that 1 gigawatt scale early 26 and full 2 gigawatt by year end. How do you think they'll utilize that in the context of scaling laws? Is a lot of that inference? Is a lot of that training?
It ends up being all of the above. So I think that all of your decisions when you're training a model come back to pre-training. So if you're going to scale RL in a model, you still need to decide on your architecture that enables this. We were talking about like other architectures than using different types of attention. We're also talking about mixture of experts models. This sparse nature of MOE models makes it much more efficient to do generation, which becomes a big part of post-training. And it's like, you need to have your architecture ready so that you can actually scale up this compute. I still think most of the compute is going in at pre-training because you can still make a model better. You still want to go and revisit this. You still want the best base model that you can. And in a few years that'll saturate and the RL compute will just go longer.
Is there people who disagree with you that say basically pre-training is dead? It's all about scaling inference, scaling post-training, scaling context, continual learning, scaling data, synthetic data.
People vibe that way and describe it in that way, but I think it's not the practice that is happening.
It's just the general vibe of people saying this thing's dead.
The excitement is elsewhere. So the low-hanging fruit in RL is elsewhere. Like, for example, we released our model in November. For every company has deadlines. Our deadline was like November 20th. And our RL run was 5 days, which compared to 2024 is a very long time to just be doing post-training at a model of like 30 billion parameters. It's not a big model. And then in December, we had another release, which was just, we let the RL run for go for another 3.5 weeks, and the model got notably better, so we release it. And like, that's a big amount of time to just allocate to like something that is going to be your peak for the year. So it's like, so there's these types of decisions that happen when they're training a model where they just like can't leave it forever. You have to keep pulling in the improvements you have from your researchers. So that's like, you redo pre-training, you'll do this post-training for a month, but then you need to give it to your users. You need to do safety testing. So there's kind of just like, I think there's a lot in place that reinforces this cycle of just keep updating the models. There's things to improve. You get a new compute cluster that lets you do something maybe more stably or faster. It's like, you hear a lot about Blackwell having rollout issues where at AI2, most of the models we're pre-training are on like 1 to 2,000 GPUs. But when you're pre-training on 10,000 or 100,000 GPUs, you hit very different failures. So GPUs are known to break in weird ways. And doing a 100,000 GPU run is like, you're pretty much guaranteed to always have at least one GPU that is down. And you need to have your training code handle that redundancy, which is just a very different problem. Mm-hmm. Whereas like what we're doing, like I'm playing with post-training on DJX Spark, or you have your book, it's like, or people learning ML, it's like what they're battling to train these biggest models is just like mass distributed scale. And it's a very different, but that's somewhat different than like, are these, like that's a systems problem in order to enable the scaling laws, especially at pre-training. You need all of these GPUs at once. When we shift to reinforcement learning, it actually lends itself to heterogeneous compute because you have many copies of the model. And to do a primer for a language model reinforcement learning, what you're doing is you have two sets of GPUs. One is, you can call it the actor, and one you call the learner. The learner is where your actual reinforcement learning updates are going to do. These are traditionally policy gradient algorithms, proximal policy optimization, PPO, and group relative policy optimization, GRPO, are the two popular classes. And on the other side, you're going to have actors, which are generating completions. And these completions are the things that you're going to grade. So reinforcement learning is all about optimizing reward. And in practice, what you can do is that you can have a lot of different actors in different parts of the world doing different types of problems. And then you send it back to this highly networked compute cluster to do this actual learning where you take the gradients, and you need to have a tightly meshed network where you can do different types of parallelism and spread out your model for efficient training. So there's just like a lot of every different type of training and serving has these considerations you need to scale. Like we talked about pre-training, we talked about RL, and then inference time scaling is like, how do you serve a model that's thinking for an hour to 100 million users? I'm like, I don't really know about that, but I know that's a hard problem. And in order to give people this intelligence, there's all this systems problems, and we need more compute, and you need more stable compute to do it.
But you're bullish on all of these kinds of scaling is what I'm hearing, on the inference, on the reasoning, even on the pre-training.
Yeah, so that's a big can of worms here. But so there are basically two. The knobs are the training and the inference scaling, where you can get gains. And so in a world where we had, let's say, infinite compute resources,